What's going on, guys? Zane here, back with another video. For this one, we're going to go over question number 200, number of islands on LeetCode. So we're given a two-dimensional binary grid, which is just zeros and ones, that represents a map of land and water. Ones are land, zeros are water. So we're given a char array as our grid, consisting of characters which are either going to be 1 or 0. So what we're doing is we're going through these values and we're checking to see, okay, is it a land piece or is it a water piece, or I don't know, an island with water or an island of land? Is an island of water a thing? Anyway, once we get to a piece of land, we need to basically check to see are the adjacent pieces also land or are they water? Now, if the adjacent pieces, meaning up and down, so horizontally and vertically, if they are also land, then we can assume that that is part of that one island. So if we were to look at this example here, we would want to check to see, is up, down, left, and right also an island? If it is, okay, it's part of it, so move on to the next value and do the same thing. So this would give you an idea that we need to use some sort of recursion. We need to constantly check until we reach a point where we are not at a 1, and then move on to our next value. So how are we going to tackle this with the code? Well, what we could do is we're first definitely going to need to loop through all of our values to make sure that we have our proper value inside of our loop. So we'll first do a for loop on the grid itself, just so that we can get the row. And then we need to get the actual value inside, since this is a double array or an array of arrays. We're going to have to go through one more time, and this time we'll set j. We're going to do grid at 0, length j++. And the reason we're doing this, and this is kind of just standard brute force of getting into a grid and calculating or figuring out what value you're at. So now we're at the very first point in our grid. So we only care about when a value is a 1. So we'll say that if the grid at I, so if the value that we're at is equal to a 1, and just as a side note, this is a char array, not an integer array, so this needs to be in single quotes. So if the value is equal to the character 1, then we need to recursively call something. So do some recursive call. What we're also going to need to do is return some integer value, which is the actual number of islands. So let's just declare that at the top. Int number of islands is equal to 0 for now. So what we'll want to do is, if the value is a 1, then we'll need to take our number of islands and then add whatever recursive call we do here in this space. So let me just put like a thing here. So this is what we need to do. And when we think of questions like this, and through some of the research that I did, I think the best or I guess the more easier way to understand it is using a DFS, or a depth first search algorithm. And what we're doing is we'll first establish that we only care about a 1, which we technically did here. And we'll also establish that we don't want to go out of bounds. So let's say, for example, we're at this value here. We don't want to go left or up because that's out of bounds. We don't care about that. So once we've established that, okay, we're in bounds and we're on a 1, then check up, down, left, and right. So maybe this one here is a better example. So we're at this one, we'll check up, down, left, right. So let's actually create some sort of helper function for that. And this one's going to return our int value. So we'll say int, and we'll just call it DFS. It's going to take in our grid. It's going to take the original grid that we have. It's going to take an integer I and an integer j. And the reason that we have these three values is only because we are only concerned with the grid. And since we have to get into our arrays using some I and j value, it could be anything really, but these are the two values I'm using to get inside of the array here. So I'm just going to put these values into the parameters here, and now we can start with our function. So let's get the edge cases out of the way. So if the value of I is less than 0 or the value of j is less than 0, we don't care about that. We just want to return a 0. And the reason for that is because we, of course, are not going to have a -1 as some index. Now, on the other end, it would be if I is greater than or equal to the length of the grid, then that's also out of bounds. Now, if j is greater than or equal to grid at 0.length, then we're also out of bounds. So these should just be your straightforward, we are staying in bounds of our grid. Now the last piece though is that if the value of grid at I at j is not equal to 1, then that is another edge case that we don't care about. So, well, technically we do care, but we're not going to actually return any actual value. All we're going to do is return 0 in these cases. Now for the meat of the problem. So we're at this position where the value is a 1. Now we need to check up, down, left, and right. So, as I mentioned, we need to do a recursive call. So all we need to do is call our function that we're creating right now. We'll call it again. We'll pass in a grid, but this time we'll pass in the up value, nj. Then we'll pass in the down value, nj. Then we'll pass in I, but with the up value for j, and then the same thing again, but this time the j values, the down value of j. So this is essentially taking care of our up, down, left, and right. Now, if there's a situation where we actually get to the end of our code, that means that all of this was fine, meaning we were in bounds, and the value was a 1. So it's not going to return 0. It's just going to constantly return back into our function here. And then lastly, we return a 1. Now, one final thing I want to make note of is that this is recursively calling the function itself. Now, to ensure that we are not accounting for the actual island that we're at, we need to set the value that we're at to 0. Once we do that, then we can let our DFS recursively do its thing. So now that we've built our DFS search function, we'll just say, okay, we'll add whatever the value of DFS is here at grid at I at j, just like we have passed here. And then lastly, returning the number of islands. Let's run this, see what's going on. Int cannot be converted to Boolean. Let's see what's going on. Line 7 and 9. Okay. Int I equals 0. Whoops. I is less than. And j is less than. Let's submit this, make sure it's good. Great. So that's it for this one, guys. If you guys have any questions, comments, feedback, please let me know in the comments below. Otherwise, hit that like and subscribe button. Show me some love. And I'll see you in the next one. Peace.